Today we are starting chapter 6 and section 6.1 is on properties of exponents. For your learning targets, you will be able to use zero and negative exponents, and you will be able to use the properties of exponents. So in our core concept, first we're looking at the zero exponent. Anytime you have an exponent of zero, your term is always going to simplify to 1. Then we have our negative exponents. In negative exponents, you're going to take the reciprocal. So the example they show you here is 4 to the negative 2 power. So you're going to rewrite that as 1 over 4 to the positive 2 power. So once you flip this, do the reciprocal, you're going to keep the 1 on top, and the exponent in the denominator now becomes positive. So when you're dealing with negative exponents, the sign of the number doesn't change. The only sign that changes is on the exponent, and it becomes positive once you flip it. Example 1 is using zero and negative exponents. So for our first problem, we have 2.5 to the 0 power. Again, anything to the 0 power is going to simplify to 1. So 1 is our answer here. In the second problem, we have negative 3 to the negative 2 power. So we have a negative exponent. So we're going to write this as 1 over negative 3 to the second power. So because I flipped this, I did the reciprocal and put this on the bottom, the exponent now becomes positive. So now negative 3 squared is really telling us to do negative 3 times negative 3. So negative 3 times negative 3 gives us positive 9. So we're going to rewrite this as 1 over 9. So whenever you have this negative inside the parentheses, it's going to be part of the base that you're multiplying together. So you will see some problems where it's the negative's not in parentheses, and that's when you're not going to be including the negative 3 as part of the base. Example 2 is simplifying an expression. So it's combining some of these properties that we've been looking at. So we have 2 to the 0, x squared over y to the negative 2. And we're going to be simplifying all of this so that we only have positive exponents in our answer. And so the way I like to do this is go term by term. So here I've rewritten the problem. 2 to the 0 becomes 1. So I'm going to rewrite my 1 up here. X squared, that's going to stay on the top as well. And then y to the negative 2. This negative exponent means that we need to multiply or move this up to the top. So I write my y squared on the top, and then now I just have 1 left in the denominator. There's nothing else here. So we're going to multiply this all together. So our final answer is x squared y squared. So these are some more properties of exponents, kind of continuing our core concepts. So first we have a product of powers. So anytime you're multiplying like bases, so I'm going to put an M here for multiply, you're going to add the exponents, okay? Add the exponents together. For your quotient property of powers, anytime you're dividing like bases, you're going to subtract the exponents. And then we have the power of a power property. So this is when you have a base to a power again. So whenever you have a power to a power, you're going to multiply the exponents together. Example 3 is now using some of these properties. So for the first problem, we have 2 to the 3rd power times 2 to the 5th power. So I am multiplying like bases, so that means we are going to add the exponents. 3 plus 5 gives us 8. And then we can go ahead and simplify this. On our calculator, if you do 2 to the 8th power, you're going to get 256. So 256 is our answer here. And the second one, we have negative 7 squared divided by negative 7 to the 4th. So we're dividing like bases. So that means we're going to subtract our exponents. When you're subtracting, you're always going to do the top exponent minus the bottom exponent. So we have negative 7 to the 2 minus 4 power, which is negative 2. So now we have a negative exponent. So this brings back what we were looking at in example 1. I need to do the reciprocal and write this negative 7 now squared in the denominator. And again, negative 7 times negative 7, so negative 7 squared is going to give us positive 49. So note the negative is inside the parentheses, so that is part of the base that we're squaring. So that's why we have positive 1 over 49 as our answer. Our last one is a power to a power. So I have d to the negative 3 power to the 5th power. So that means that I need to multiply these bases. So I have d to the negative 3 times 5 power. So this is going to give us d to the negative 15 power. Again, this is bringing back that negative exponent rule, meaning we have to take the reciprocal. So this becomes 1 over d to the positive 15th power. And there's nothing left for us to simplify here, so that's our answer. Here are some more properties of exponents. So you have the power of a product as well as the power of a quotient. And so what this is saying is that if I'm multiplying two numbers together and they're raised to an exponent, I'm going to kind of like distribute that exponent to both of those bases. Same thing when you have a quotient. So I have a number over another number raised to a power. I'm going to apply that exponent to both of those terms. So example 4 is using these properties. So for the first one, we have the quantity negative 3x to the 3rd power. So we're going to apply the power of 3 to both the negative 3 and to the x. So negative 3 cubed is really saying negative 3 times negative 3 times negative 3. So negative times a negative is positive, times another negative is going to be negative. And 3 times 3 is 9, 9 times 3 is 27. So this is going to give us negative 27x cubed. So this is our final answer for the first one. So the second one, we have the quotient. So we have b over negative 3 to the 4th power. So again, you apply the 4th power to both the b and to the negative 3. So b to the 4th power is going to become b to the 4th power. And then in the denominator, you have negative 3 times negative 3 times negative 3 times negative 3. So because this exponent is even, all the negatives are going to cancel out. So 3 to the 4th is going to give us 81. So our answer here is b to the 4th over positive 81. Okay, so this next one, we have 2x over 5 to the 3rd power. So this kind of combines both the power of a product and power of a quotient. So this 3 has to apply to the numerator and the denominator. And then going back within the numerator, it has to go to the 2 and to the x. So when I rewrite this, I'm going to have 2 to the 3rd power times x to the 3rd power all over 5 to the 3rd power. So now we're going to go ahead and simplify these out. So 2 to the 3rd power is 8. X cubed is going to give us x cubed. And then 5 to the 3rd power is 125. So our final answer here is 8x cubed over 125. So again, finally, our last one is similar to what we did in C, but we're starting here with a negative exponent. So we want to get rid of that negative exponent. So our first step here is going to be to take the reciprocal. So we have 4 over 3c, and now our exponent becomes positive. So then it becomes a problem like we did over here. So we're going to apply the square to each term. So in the numerator now we have 4 squared. And then in the denominator, we're going to have 3 squared and then c squared. So 4 squared, 4 times 4 is 16, over 3 squared is 9, and then c squared is going to stay c squared. So our final answer here is 16 over 9c squared.